Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Cagey Sightline Yin Yang by Yitrio, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which is a box. We also have yin-yang shading, where we need to shade some cells such that all shaded cells are orthogonally connected, and all unshaded cells are orthogonally connected also. And no 2x2 area is fully shaded or fully unshaded. So this is a valid yin-yang shading, because all the shaded cells are orthogonally connected, which means you can go from one cell in the shaded region to any other cell in the shaded region just by going through edges, all while staying within the shaded region. And the unshaded cells are also all orthogonally connected for the same, and that's the same definition, right? You can go from any cell in the unshaded region to any other cell in the unshaded region just by going through edges, all while staying within the region. And then there's no 2x2 area that's fully shaded or fully unshaded. So for example, this would not be a valid shading because the unshaded region would be blocked from the rest of its region, because you couldn't go from this section to this section without either going through a corner or without switching regions. And this would not be valid as a yin-yang shading because there's a 2x2 region that is fully unshaded, which is not allowed. So that's how yin-yang works. We also have digits cannot repeat within a cage. And the sum of the cells in a cage is equal to the total number of cells the marked diamond cell in that cage sees in all horizontal and vertical directions combined, including itself, that have the same shading as the marked cell, which is the diamond. So cells of the opposite shading block the vision. So, for example, the sum of this cage must equal however many cells this shaded cell sees, right? Because since it's shaded, it must see itself. It sees this two, so it'd be 1, 2, 3, 4, 5, 6, 7. So this cage would have to add up to 7. Same with this cage, right? This cage would add up to 1, 2, 3. Okay, if this was a valid shading, it would be 8. This would have to add up to 7. 1, 2, 3, 4, or 8 actually. 1, 2, 3, 4, 5, 6, 7, 8. This cell would have to add up to, this cage would have to add up to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So would this cage, because it sees all of these and it sees the entire right side column. And that's how the cages interact with the diamond cells. The cages must the digits in the cage must sum to however many cells the diamond cell in that cage sees of its own shading. And again, you're blocked by vision, so this does not see these cells because it's blocked by the opposite shading. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So, let's look at the largest one. This must be at least 15 to add up to what this is. So this must see 15 cells at least. Well, it sees at most 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. But if it saw all 17 here, the problem is that it would basically be, this would all be the same shading no matter what. And then this part, it couldn't be all the same shading. It couldn't be all shaded because then this 2x2 area would not work. So again, this must add up to 15 at least. That means this is at minimum 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then 15 has to be one of those. So, and this is at least 9, right? So this is at most what this is, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then one of these, 15. So this is guaranteed to be at least this. So we're going to mark this as the same shading. It must be, so this is, it could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is guaranteed to be there at least, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is at least blue. So, none of these 2x2 areas can be all blue, so therefore some of these are green, and it must be all green to connect to the rest of the green. So, either this is green, which forces all of this to be green, or this is blue, which forces this to be green, which forces all of this to be green. So this is all green. This must be green because this 2x2 area cannot be all blue. This has to be green, so therefore this must be green going this way. And this is a 2x2 area which has 3 greens in it, so this can't be green, that must be blue. So this must be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14. So at least one of these is blue. It could be more. This green has to go out, so let's go to there. So the sum of this cage is either 1, 2, 3, 4, 5 or 1, 2, 3, 4, 6, because it must add up to 16 or 15, which means the rest of the row must be 5, 6, 7, 8, and 9. Okay. This must see 10 cells? Okay, hold up. That's not correct then. Oh, I guess this side, this doesn't have to be green. Yeah. This sees at least 10. And it can't just be 9 here. So if this is blue, that would force this only to see 9. So this has to be green this way. So this must be 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this sees at least 10. So it's 1. I think this has to be blue. If this is green, then this would be a 2x2 area that's all green. So this has to be blue here. Could be blue here. So since this is blue, so in yin-yang shading, you cannot, you can only switch colors twice around the grid. And the reasoning is if we try to switch twice, more than twice here, so say this was all green here, then the problem with that is how would this green connect to this green and then this blue connects to this blue region? You can't. So once we know this is blue, it's already swapped once here. It must swap again here, so this must be all blue then here. That forces this to be green. That forces that to be green. This green has to connect to the rest of the greens. This sees 1, 2, 3, 4, 5, 6, 7, 8, 9. It could be one that way, though, so it doesn't have to go there. This also sees at least 10 digits. So it must be blue that way, right? This is 9 here. This is blue. Since that's blue, this must be green. This must be green. So we know this is 15, right? Because it sees 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is exactly 1 through 5, which makes the rest of row 1, 6 through 9. This sees only 9 cells, so this cage has to be not adding up to 9. So this is a 6, which makes this 1 and 2. Because this must be green because of this 2x2 area is all blue except for that cell. That eliminates 6 in the rest of the row. It also eliminates 1, 2, and 6 in the rest of the column. So this is 3, 4, 5, 7, 8, 9. This must be at least 10 because there are no repeats. This is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It could be 10 or 11. So this is 1, 2, 3, 4, or 5, right? It could be 1, 2, 3 with 4 or 1, 2, 3 with 5. Either way, first of all, 1, 2, and 3 are guaranteed to be in this set, right? Because it must be 1, 2, 3, 4 or 1, 2, 3, 5 to add up to 10 or 11. So this cannot be 1, 2, or 3. It must be 4 or 5 here. That also means the rest of column 1 is not 1 through 5 because of the 1 through 5 quintuplet. So this is 6 through 9 here. Okay. This sees at least 10. It could be here. This sees 1, 2, 3, 4, 5, 6, 7. So this must add up to 7. It's either 1, 6, 2, 5, or 3, 4. Actually, it could be more than that. You could see this way. Okay, so that's not true. Let's keep looking at the ones on the edges. So this is done. This is kind of done. This sees a lot. So it sees 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So at least 16. So this is either 7, 8, or 9, with one of these being a 9. So it could be 7, 9, or 8, 9 here. And one of these is a 9. So this cannot be 9 here. This cannot be 9 in either of these cells. Okay. This is 4 digits also, so this must be blue. Since this is blue, this is a 2x2 area with all blues, so this must be green. This is a 2x2 areas with 3 blues, so it must be green here. Okay. Let's see. Goes that way. Okay. In this box, in the rest of box 3, we have to have 3, 4, 5, 7, 8, 9. Okay. That doesn't necessarily... Okay, so if this is blue, we're extremely limited on what this can be. Right, if this is blue, That forces green to go out this way. This would be at most 1, 2. It cannot block the green. So that would be 1, 2, 3, 4, 5, 6, and it could be 7. But because it can't block the green, that's 7 at most. That's blue, if this is blue. And that's not possible, because this is 3 and 4 at the minimum. That's 7 already, and this is another digit. So that adds up to 8 at least. So this cannot be blue, therefore it's green. It sees at most... it sees at most 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9. But it can't even see that, because if it saw all of that green, the problem is you can't have 2 greens and 2... I guess it could be alternating. So this sees at most 1, 2, 3, 4, 5, 6, 7, 8, 9 green cells. It cannot see 7. So if this were blue, it would only see 7 possible. So this cannot be blue. It's green also. So it sees 1, 2, 3. So it sees at most 9 here for this diamond. So this must be not 7, 8, or 9. It has to have a 3. It cannot be 1, 4, 5, because that would be 10 cells that it sees. So this is guaranteed 3, which means this can't be 3. And this is 1 or 2 here, because it must add up to at most 9. I guess it could be all green here if this is blue, green, blue, green. Oh, that's a problem. No, then it can't be that way. So it can't be the full 9. Okay, so this must see 1, 2, 3, 4, at least 5, 6, 7, 8. So this is guaranteed to be green. Because of that, okay, if we tried to make this green, this would be blue, because otherwise this would be a 2x2 area that has 4 greens. So that would be blue, which would force this to be green, which would force this to be blue, which would force that to be green, but then you'd have a 2x2 area that's all greens. So that's not allowed. So this has to be 3 and 4 as a pair, and this must be a 1. So 4 is not here. This sees 8 exactly. So this must be blue, because if it weren't, the problem is that we have that pattern that we talked about. So this must be green. This is a 2x2 area that has 3 greens, so this must be blue. This is a 2x2 area that's all blue, so this must be green, which forces this to be blue. And that's valid. So this sees 8, 1, 2, 3, 4, 5, 6, 7, 8 greens. This must be blue because of the 2x2 area that's all greens so far. This is a 2x2 area that's all blue, so this must be green. Since these are... okay. I went over this very quickly, but... well, this one was obvious because this couldn't connect to the rest of the green area unless it went out that way. But anytime you have, for yin-yang shading, anytime you have a diagonal of the same color, you cannot have another diagonal of the opposite color here. And the reason why is, how do you connect all of the blue regions orthogonally and then connect all the green regions orthogonally? The answer is you can't. So anytime you have a diagonal of the same color, you must have one of the opposite color and one of the same color. Obviously, if you have both of the opposite color, then you have the problem of connecting orthogonally both sets of shadings. If you have both of them the same color, then you have a 2x2 area that's all fully unshaded or shaded. So this must be green, because this is blue. We have a 2x2 area that's green, that's 3 greens, so this must be blue. Okay, this must add up to 9, because that's how many it sees. So this cannot be 9 here. This must be 7 or 8 with 1 or 2. That means 9 is guaranteed to be one of these two cells in row 1, so that eliminates 9 in the rest of that box. Okay, the remaining digits in column 8 are 2, 5, 6, 7, 8, and 9. This sees currently 1, 2, 3, 4, 5, 6. Could be more. This sees currently 1, okay, so 6. What can it see up to? Quite a bit, actually. Don't know anything about this. So this is 9, which eliminates 9 in the rest of the box. And the rest of the row. But that's not saying much. This sees 10, at least. Could be more, could be less. Could be 3, 4, 3, 4, 2, and 1. That is possible. This, again, sees only 9. This sees 15. This could be... So it could be 1, 2, 3, 4, 5, 6, 7. It could be 8, 9, 10, 11. That's all it could be. So up to 11, but that's still pretty broad. Okay. One of these two cells is green. One of them has to be blue, though. Because if both were green, that'd be 2 by 2 area that's all green. If they're both blue, the green doesn't connect as a region. So one's green, one's blue. We're not sure which is which. Okay, if this is blue, that means it would see guaranteed 1, 2, 3, 4, 5, 6 at most. If this is green, it would see 1, 2, 3, 4, 5, 6 at most. So this is at most 6. Either way. Interesting. Obviously, this blue cannot go all the way across. It could go, because then that would block the green area from being connected orthogonally. It could be up to, so this is 9, 10, 11, 12, 13, 14 at most. That means it can never contain a 9. It could be 1, 2, 3, 8 at most, adding up to 14. It could be 2, 3, 4, 5. So either this is 1 here, or it's 2, 3, 4. Okay, this can't be 5 because of one of these is a 5 guaranteed. So this can't be 5 either. But either you have a 1 here, and the rest is fine. It could be 2, 3, 8. Or... So this can never be 8 there, because that would force us to be 8, 3, and 4. And this sees only 14 cells. Or this is all 2, 3, 4, 5 here. So it could be 2, 3, or 4, 3, 4, or 5, or 2 or 5 there. Okay. This is 8, right? 1, 2, 3, 4, 5, 6, 7, 8. Yep. This is 9. This is at least 10. Could be up to 14, technically. This is 16 or 17. Not sure which. This blue must connect out. Okay, how many can this see? This sees 1, 2, 1, 2, 3, 4, 5, 6, 7, 8 at most. Right? It cannot be just 4, because if it were just 4, the problem is that this would have to be 1 and 3, but we already have a 1 in the row. So it must go to here. This is green. This 2x2 area has 3 green, so this can't be green. This is blue. So this sees 1, 2, 3, 4, 5, 6, 7, 8 cells. So this must be 1, 7, 2, 6, or 3, 5. We have a 2x2 area that's 3 blues, so this must be green. This must connect then, so this must be green that way. It either connects here and then connects here or something like that. This then either is 1, 2, 3, 4, 5, 6, or 7, 8. So this is 6 or 8. If it's 6, it's 2 and 4. If it's 8, it could be 2, 6, or 3, 5. So those are the possibilities. One of these is blue, one of these is green. Interesting. If this is blue, then both of these, well, this would have to be green, and then this would be blue. Oh, if this is green, we have a problem. Well, not necessarily. If this is green, this cannot be green because this 2x2 area would have 3 greens in it. So this would be blue. So this would C3. If this is blue, it cannot go the full amount. Because then there was blocked this green from actually coming out. Oh. So this can't be blue. If this is blue, this green has to go out this way. And then this would see 2 cells, which is not possible for a 2-cell cage to add up to. So this cannot be blue. This must be green, since this is a 2x2 area that's all green. I'm sorry, that has 3 greens, so this must be a blue. Therefore, these are both blue, so it must connect that way. That's a blue. Because otherwise you'd have that cross-diagonal thing for the yin-yang. This green must go out, so it must go there. This sees only 3 cells that are green. So this must be a 1-2 pair, which eliminates 1 and 2 in the rest of the row. So this can't be 1 or 2. This can't be 1 or 2. This can't be 2. Okay. One of these is blue, one of these is green. We don't know which. This sees at least 11, right? 9 here, 10, 11. And it could be 12, 13 at most. So this can no longer have an 8 as the max. So therefore, this has to have a 1, because there's no guarantee of... You can't have 2, 3, 4, 5 add up to 13 or less. And this is 13 or less guaranteed, right? This is 9, 10, 11, 12, 13 at most. So this has to be a 1, which means this can't be 2. That's 2, which makes that 1. So this can no longer be 2. Therefore, to add up to 13, it has to be 3, 4, and 5. And it has to add up to 13 then, because that's the minimum for this cage. 1, 3, 4, 5. So this is 3, 4 pair, which eliminates 3, 4 in the rest of the column. So this can't be 3 or 4. This 5 eliminates 5 in the rest of the box. We have a 6, 7, 8, and 9 quadruplet. Actually, we have a 7, 8, 9 triplet, which eliminates 7, 8, and 9 in the rest of the box. So this can't be 7, 8, or 9. It's 6. That forces this to be 3 or 4. We have to have, this adds up to 13, so this must be all blues. That means this has to connect to the green, otherwise it can't be connected. So we have a 2 by 2 area that's all green. That's 3 greens, so this must be blue. This 5 and 6 are eliminated in column 8. So this is 5. 5 has to be one of these two. This sees, it must see 10. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this must be blue, which means this sees only 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this must be 1 through 4. This has to be 1, 2, 3, 4, and this cannot be 1, so where's the 1 in this cage? It must be here. That forces this to be 2, 3, and 4. Obviously, this can't be 2 because of the 2 in the row. We have a 2, 3, 4 triplet. Okay, so this sees 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So this must add up to 17. Therefore, it's an 8, 9 pair, which eliminates 8 and 9 in the rest of the box. It's a 7, which eliminates 7 in the rest of the column. We have a 3, 4 pair in row 8, so that forces this to be 5, 8, or 9. This 8 or 9 eliminates 8 and 9 in the rest of the row, so this is 6 or 7. This is 5, 6, or 7. This is 5, 6, or 7. This adds up to 10 because that's how many it sees. This sees 8, I think. 1, 2, 3, 4, 5, 6, 7, 8. So this must be 8, which means it's 2, 6, or 3, 5. This sees a lot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's either 2, 9, 3, 8, 4, 7, or 5, 6. This is done. This sees 7, 8, 9. So this must be either 1, 8, 2, 7, 3, 6, or 4, 5. Cannot be 1, so this can't be 8. This can't be 2, 3, or 4. So that eliminates 7, 6, or 5. This 5 eliminates 4 here, because this can't be 5. Remaining digits in box 8 are 5 through 9, and this can't be 5 here, so it's 6, 7, 8, 9. This adds up to 9 there. This is done there. So is this. This 1, 2, 3, 4 eliminates 1, 2, 3, 4 in the rest of the column, so this is 5, which eliminates 5 in the rest of the row. Okay. So this is done. It sees, okay, this sees 3. This is done. It sees 15. So 9, 10, 11, 12, 13, 14, 15. This 1 eliminates 1 here, so this can't be 1 here. This can't be 1 because of the 1 in the row. So where's the 1 in column 1? It must be here, which eliminates 1 and 7 as a possibility in this box. Okay. This 1 eliminates 1 here, so this must be 2 and 7 to add up to 9. That eliminates 7 in the rest of the row. So this becomes an 8-9 pair. That eliminates 8 and 9 in the rest of the box. So this is a 5-7 pair. We have an 8-9, 8-9 pair in column 8, which eliminates 8 and 9 in the rest of the column. So this is now a 2-7 pair here. This 2 eliminates 2 here and eliminates 2-9 as a possible pair for this 11 cage, right? This is again 7, 8, 9, 10, 11. And this eliminates 4-7 as a possible 11 cage. Okay, this 7 eliminates 7 in the rest of the column. 2 has to be one of these 2 digits. We know 1's one of those. Okay. This sees right now 1, 2, 3, 4, 5, 6. And we cannot have 1 or 2 in this cage. So it's at minimum 3, 4. So this is at least green. Therefore, the blue has to go down and down to connect with the other blue. So this is either... Okay, so this is a 2x2 area that has all blue. So this must be green. So the C's, how much? 8? So 5, 6, 7, 8. Yes, 8. So this must be either... This must be 3 and 5 as a combination. This 3-5 pair eliminates 3 and 5 in the rest of the column, so this can't be 5. This is 6, which means this can't be 6. This can't be 6 here either. We have a 7, 8, 9 triplet, which eliminates 7, 8, and 9 in the rest of the box. This can't be 8 or 9, so it's 5. That eliminates 5 here. This 6 eliminates 6 here, so it's 7. This can't be 6 or 7, so it's 5. 7 eliminates 7 in the rest of the column. 7 or 8 adds up with 1 or 2 to add up to 9, which is how many this diamond sees. Remaining digits in column 6 are 4, 8, and 9. And 4 has to be one of these 2. Okay. This 5 eliminates 5 from this column. So this can't be 5, which means this can't be 6. This 5 eliminates 3 here. This is either 3 or 5, and this is either 3 or 5. That eliminates 3 or 5 in the rest of the box. So this can't be 3. This is a 1-4 pair, which eliminates 1 and 4 in the rest of the row. So this is 2 and 3. It also, this 3-5 pair, this being 3-5 and one of these being 3-5 eliminates 3 and 5 in the rest of the row. So this can't be 5, that's 7, this can't be 3, so that's 4, which makes this 3, which makes that 5. This 2 eliminates 2 here, so that's 1 and 2. Remaining digits in box 2 have to be no 3, 5, no 1, 2, 4, 7. So it's 9 as one of these 2, and then 6 or 8. And we have a guaranteed 9 here, so this cannot be 9. We have a 6, 8, 9 triplet in row 2, which eliminates 6, 8, 9 in the rest of the row, so this must become a 4, 7 pair. And this has to be 1, 6, 8, or 9. Well, this can't be 1. Where is the 1 in box 1? It has to be here. So this is 1. This is a 3, 5. So if this were 3, 5 adding up to 8, that would eliminate all possibilities for this cell. So this cannot be 3 and 5. It must be a 2, 6 pair, which eliminates 2 and 6 in the rest of the row and the rest of the box. So this can't be 6. This 2, 6 pair eliminates 2 here. So this is 1 and 8 to add up to 9. That 8 eliminates 8 here, so it's 9. This can't be 8 or 9, so it's 7. This 1 eliminates 1 here, so it's 4, which makes that 1. This 9 eliminates 9 in the rest of the column, so this becomes a 4-8 pair. One of these two digits must be a 6 for column 1, so this cannot be a 6 here. Remaining digits in box 5, we have 3, 5, 7, and 9. 7 cannot be here. Where is the 7 then? In box 5, it has to be here. So this is 7, which eliminates 7 here, so that's 2 and 7. 2 eliminates a 2-6 pair here. This 5 eliminates 5 here, so this is 3 and 5. This 3 eliminates 3 here, so that's 2 and 3. This 2 and 3 are eliminated. This can't be 1 because of the 1 in the row. So where is the 1? It must be here. This 3 and 5 eliminate 3 and 5 here, so it's 9. This can't be 5 and 9 anymore, so it's 8, which forces this to be a 5 here. This 8 eliminates 8 here, so it's 9 and 8. This 3 eliminates 3 here. Okay. This 5 eliminates 5 here, so this is 3, which makes that 5. This cannot be 5 and 6 anymore, so this becomes a 3-8 pair, which eliminates 3 and 8 in the rest of the row and the box, so this can't be 8. This 9 eliminates 9 here, so it's 6 and 9. This 8 eliminates 8 here, so it's 3 and 8. This 6 eliminates 6 here, so it's 2 and 6. That means this can't be 3 or 4, so this is 2, which means it eliminates 2 here. This can't be 3 or 9, so that makes that 5. This 8 eliminates 8 here, so it's 4, which makes that 8. Okay. Remaining digit in row 5 is a 6. Remaining digits in box 6 is 3, 4, and 9. So this is this, and this 8 here eliminates 8 here, so this is 9, which makes that 8. So it's still 3, 4, or 9. Cannot be 3 because of the 3 in the row. This is 3, 4, or 9. Remaining cells in row 4. Well, we have all the 1s. 2s are kind of limited. 3s, not sure. 4s, not sure. 5s, 2, 3, 4, 5, 6. We have all 9 5s. 6s are kind of... Oh, this 6 eliminates 6 here. So it must be 8, which means this can't be 8. That's 9, which means this can't be 8 or 9. So it's 6. 8 eliminates 8 here, so it's 9, which means this can't be 9, so it's 4. This 4 eliminates 4 here, so it's 3. This can't be 3 or 4, so it's 9. This 4 eliminates 4 here, so it's 3. That makes this 4. This 3 eliminates 3 here, so it's 4, which makes that 3, which makes that 4. This 4 eliminates 4 here, so it's 2. This can't be 2 or 4, so it's 3. This 9 eliminates 9 here, so it's 8 and 9. This must be left over in row 7 is 2 and 6. 2 can't be here because of 2 in the column, so it's 6, which makes that 2. We have 4 and 6 remaining in row 6. This can't be 6 because of the 6 in the column, so it's 4 and 6. 4 eliminates 4 here, so it's 7 and 4. That leaves this as an 8 and this as a 7. And just to make sure that we have this all added up, this adds up to 15, which this diamond sees. It sees 9, 10, 11, 12, 13, 14, 15. This cage sees 9, which exactly is what this diamond sees. This cage adds up to 9, which is exactly what this diamond sees. This cage adds up to 8, which is 1, 2, 3, 4, 5, 6, 7, 8. This sees 8, 2. It's 3 and 5 add up to 8, so it's 1, 2, 3, 4, 5, 6, 7, 8. This cage adds up to 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This cage adds up to 8, which it sees 1, 2, This is 7 plus 8. This cage adds up to 8, which is what it sees, 7 plus 8. This adds up to 10, which is what it sees, 7, 8, 9, 10. This cage adds up to 9, and it sees 7, 8, 9. This cage adds up to 13, 1, 3, 4, and 5, which is what it sees, 9, 10, 11, 12, 13. This cage adds up to 10, which is what it sees. 9 plus 1 is 10. This sees 3, which it adds up to. And this sees 17, which is what it adds up to. 9 plus 8. Interesting. Very cool, actually, use of the sight lines, the Cagey sight, to restrict things a lot. Yeah, it was fun. I hope you had fun watching this solve, and I'll see you next time on Frank Puzzles. Take care.